Hi everyone, let me hope you are doing fine wherever you are. Today I want to teach you something more about integral calculus, and that is the partial fractions. We want to discuss integration by partial fractions, but before we go ahead and look at integration by partial fractions, we need to understand what a partial fraction is. Okay, so partial fractions. This lesson is for advanced level students. It's not for ordinary level students. You know, I teach both advanced and the ordinary level, so I have to specify at the start of the lesson. If we are to understand the partial fractions, we need to first go back to the arithmetical simplifications consisting of a number of fractions. How do we simplify if we are given a situation like 2 over 5 minus 3 over 4 plus 1 over 2, okay? What we need most if we are to simplify this fraction is to find the LCM of 5, 4, and 2, and that's 20, okay? So we get 20 and divide by 5. 20 divided by 5, you end up with 4. 4 times 2 is 8, okay? 20 divided by 4, you get 5. 5 times 3 is 15, okay? Then 20 divided by 2 is 10. So 10 times 1 is 10. Now 18 minus 15, you end up with 3 out of 20, okay? So in just the same way, we are going to simplify algebraic expressions consisting of a number of fractions. So what do we do? In just the same way we have simplified these arithmetical fractions, is the same way we are going to simplify algebraic fractions. We need the denominator, okay? And then look at these denominators and find their LCM. Then you combine the fractions and come up with, a combined fraction, okay? So, this part of partial fractions, we are basically looking at the algebraic fractions, okay? How to break, a combined fraction into simpler fractions, or how to combine fractions into, a single fraction. That's what we are going to discuss here in partial fractions. Let's look at an example and see how this is done. It is really very easy. It's all about finding the LCM, and the LCM of algebraic fraction is simply a product of the denominators. For example, okay, with the 2 over x minus 3 minus 4 over x minus 1, okay, the LCM of the denominators is, there is an aeroplane making a lot of noise, but it is okay, is x minus 3 to x minus 1, okay? That's something simple. So let's try to combine these two fractions and see what we end up with. It's something very simple. It should be done by anybody at any time t, okay? So what do we do? 2 over x minus 3 minus 4 over x minus 1 will give us, okay, x minus, this x minus 1, x minus 3 into x minus 1. So we get our LCM and divide by x minus 3. If you have x minus 3 into x minus 1, then you divide this by x minus 3. This cancels out, and then you end up with the 2 into x minus 1. Similarly, this will be minus 4 into x minus 3. Okay, now next step is just opening the brackets. This is gonna be 2x minus 2 minus 4x plus 12. Okay, so all over x minus 3 into x minus 1. Okay, so what do you get when you combine 2x minus 4x is minus 2x, and the 12 minus 2, so you end up with 10 minus 2x out of x minus 3, okay, into x minus 1. So this is a single fraction, okay, which is a result of the combination of the other two fractions on the left-hand side. All right, we have seen how to combine these two simple fractions into a compound algebraic fraction. Now, the two fractions on the left-hand side are what we call partial fractions of the expression on the right-hand side. But, you know, they will not give us simple fractions and they want us to combine them into a single fraction. In practice, what is going to happen, they will give us this fraction which is combined, not exactly this, but they will give us a compound, you know, algebraic fraction, and they want us to go back into the component fraction, which we call partial fraction. So we must know how to break or how to decompose this single fraction into partial fractions. Okay, what do? We simply follow the rules of partial fractions. So let's see some of the rules that we follow to break a compound algebraic fraction into partial fraction. So rule number 1 is the numerator of a fractional function must be of lower degree than that of the denominator. Okay, if not so, we divide out by long division to obtain a polynomial with a rational remainder, where the remainder has numerator with degree less than that of the denominator. We want to explain about this rule number 1. Okay, it should be fully understood. Look at this. The function okay, 2x squared plus 3 over x cubed minus 1 can be expressed in partial fractions. Okay, why this can be expressed in partial fraction is because the degree of the numerator is 2 and that of the denominator is 3. Now 2 is less than 3. Okay, rule number 1 says that the degree of the numerator must be less than that of the denominator. Okay, so whereas, okay, let's look at this other. Okay, whereas the function 2x cubed plus 3 over x cubed minus 1 cannot be expressed directly. Okay, now why can't we express this directly? Because you are saying that the numerator here is of degree, this is degree 3 and this is degree 3. They are of the same degree. Okay, so if they are the same degree, then we have to calculate long division. Okay, you cannot, the first one, this can be expressed directly. There's no question about that. Okay, you just follow other rules which we are going to write down in a minute. But the second cannot be expressed directly because the numerator, look at the degree of the numerator and that of the denominator, they are the same. Okay, so in that case, you need to go to long division, okay? Obtain a polynomial and a rational remainder, okay? So what do? You remember we have talked about long division. We have to get 2x cubed plus 3 out of x cubed minus 1. Then this, you get a 2. Then this will be 2x cubed minus a 2. So if you subtract it, you end up with the 5, okay? Now, this will be, it will mean that 2x cubed plus 3 out of x cubed minus 1 is equal to 2 plus, okay, 5 over x cubed minus 1. Now, this can now be expressed into partial fractions because the numerator has degree, that's the polynomial degree 0, okay? Has degree 0, which is less than 3, okay? And therefore, we follow other rules of partial fractions. So I'll be writing these rules in a minute, okay? Don't worry about that. But the first rule, the first test, if you are going to express something in partial fraction is look at the degree of the numerator and that of the denominator. If the numerator is of lower degree than that of the denominator, then you start expressing, okay, the expression into partial fractions. Remember, these are compound fractions that, they have combined the smaller fractions to come up with a compound fraction. And the task we are going to perform is to break the compound fraction into simpler fractions. Yes, this can simplify. It can go to partial fractions, but we need to know more rules. So what is rule number 2? So we now have rule number 2. It says factorize the denominator into its prime factors. Any linear factor ax plus b in the denominator of a rational function gives a partial fraction of the form a out of ax plus b, where a is a constant, okay? Now, let's look at this example, okay? They are saying that we express, okay? Let's express this in a partial fractions, okay? Let us first look at rule number 1. Is this passing rule number 1 or not? So if it violates rule number 1, what do? Look at the degree of the numerator, okay? The degree here, when I check the numerator, this degree 3 and this degree 2. Rule number 1 says that the degree of the numerator must be less than that of the denominator. If not so, call out a long division. So let's first call out a long division to see what we get. Remember, if you're just joining us, we discussed polynomials. You can always go to my channel, okay? If you don't see the lesson, just type in Erisa Wante on YouTube. It will bring you the information I have worked on before. So we discussed the polynomials. And in polynomials, we discussed long division. So we are going to count a long division and see what we get. Okay, what do? Get 2x cubed and divide by x squared. So if I have 2x cubed and I divide by x squared, this cancels this and only remain with 2x. So here I will get 2. I will get 2x. Okay, let's multiply back. We have 2x cubed. Now when you multiply, you are multiplying through by everything here. Plus 4x squared minus 2 times 24 is 48x. Now subtract. Okay, so this goes to 0. Okay, what about 3x squared minus 4x squared? You get minus x squared. What about 54 minus negative 48? It will be the same as 54. Okay, 48 minus 54. So this is minus 6x. Then there is nothing which is subtracting from 50, so it will be plus 50. Okay, next, what do? Okay, I don't always prefer writing zeros. So what do? Next, what we do, we get x squared and divide by x squared. So this is minus, you have a minus 1, okay? So minus x squared minus 2x plus 24, okay? Subtract. What do you get? This is a 0, okay? And here we have a minus 4x. Then this is plus a 26. Okay, so what is now the fraction? So after this long division, then we can write that 2x cubed plus 3x squared minus 54x plus 50 out of x squared plus 2x minus 24 will give us this polynomial, which is 2x minus 1. Then the remainder is plus 26 minus 4x out of x squared plus 2x minus 24. Okay, now we have broken this, into something which is a bit simple. And why we have done that is we wanted to have a numerator which is of lower degree than the denominator. So we now have this fraction. This now goes further and we break it into partial fractions. We now consider, okay, 26 minus 4x out of x squared plus 2x minus 24. So rule number 2 says you factorize the denominator into its prime factors. Now, if I check here, look at the denominator. What are the prime factors? Two numbers that adds to 2 and multiplies to negative 24 is 6 and negative 4. So this goes into x minus 4 into x plus 6. Okay, and the up, we have not changed anything. We have 26 minus 4x. So we now want to look more at this rule number 2. Okay, it is talking about a linear factor in the denominator, giving us a certain type of partial fractions. So let's look at it. So here rule number 2 now comes into full use. Okay, look at the denominator here. This is a linear factor and this is a linear factor, and the rule number 2 says a linear factor gives the partial fractions of the form. So here I have a out of x minus 4 plus another constant. Let's just not use only a, plus b over x plus 6. This linear factor has given us this partial fraction, and this other linear factor will give us the second partial fraction, and the two partial fractions are added together. Okay, so the next task is to find the value of a and the value of b. Look at what I'm doing here. I'm saying they are identically equal. Okay. When I get the value of a and b, then I will equate. But here I say it is equivalent to. Okay, let's go ahead and get the value of a and the value of b. Now, 26 out of 4, 26 minus 4x out of x minus 4 into x plus 6, okay, will be equal. Let's get the LCM on the other side. What surprises you? They will be the same exactly. X plus 6, okay. This is a into x plus 6 plus a b into x minus 4. Okay, so what do we get? Let's continue with the other side. Okay, equivalent. Oh, sorry, this is equivalent. So still equivalent. Okay, the 26 minus 4x. You know why? The denominators are the same, so we just equate the numerators. Is a, this is equal to a x plus 6a. I'm now expanding, plus b x minus 4b. Okay, now before we expand, we can find the value of A and B. But anyway, let me, I think to ensure that you understand this so well, let me do this. Okay, let me just write without wasting time. There are so many ways of getting the constants A and B, but the easiest is simply write A into x plus 6 plus a B into x minus 4. Look for an x value which makes this bracket 0. That is, x is equal to 4. 4 minus 4 is a 0. Okay, so if x is equal to 4, then you're going to have 26 minus 16 is equal to A into 10, 4 plus 6 plus B into 0. And therefore, what's the value of A? A is equal to, this is 10 out of 10, which is equal to 1. Okay, then next we look for another x value which makes this bracket 0. Okay, now here we substituted if x is equal to 4. Now if x equals to negative 6, okay, we have 26 plus a 24 will be equivalent to A into 0 plus B into minus 10. Okay, so what is 26 minus 25? I think this is 50. Okay, 50 is equal to minus 10B. Okay, implying that B is equal to a negative 5. Okay, so from that we go back and make a substitution. We can now write the expression, okay, that was given to us, and then the partial fraction is, remember, we were given 2x cubed plus 3x squared minus 54x plus 50, okay, out of x squared plus 2x minus 24. And now we are saying that this is equal, don't forget our polynomial we got, but this remainder is what we have been working, with to express into partial fractions, and we have got this as 26 minus 1 plus, okay, a 1 over x minus 4, then minus a 5 over x plus 6. So it's now fully expressed into partial fractions. We have used rule number 1 and rule number 2 to break it. Okay, so next we discuss rule number 3, 54x plus 50 out of x squared plus 2x minus 24. Okay, next we discuss rule number 3. We have discussed rule number 2. Rule number 1, so let's look at rule number 3. Okay, rule number 3, what does it say? 3. Rule number 3 says, if you have a linear factor in the denominator, which is powered, R is a positive integer, okay? R belongs to positive integers, okay? R is a positive integer, not a fraction always. It is a positive integer, either 1, 2, 3, 4, whatever, okay? If you have a linear factor of such a form, then it will always give you partial fraction is A over plus B over plus, not until you reach that power, that's when you stop, okay? So let's look at an example here. Look at this example. They want us to express x squared out of x minus 3 cubed into partial fractions. So what's the solution? Okay, we have x squared over x minus 3 cubed, okay, is equivalent to A over x minus 3 plus a B over x minus 3 squared, then plus C over x minus 3 cubed. Okay, now here we have not looked at rule number 1 and rule number 2 because, first of all, the numerator is of lower degree than that of the denominator, and the expression is factorized out. Now, what do? We find the LCM, but you discover that x minus 3 cubed, okay, can be divided by n of this, okay? It divides, okay? It can be divided rather, okay? So we have a into, if you get x minus 3 cubed divided by x minus 3, then this will be x minus 3 squared, okay? Let me write it so well. This is x minus 3 squared plus a b into, if you get x minus 3 cubed and divide by x minus 3 squared. Remember, there are 2 brackets repeating down, and these are 3 brackets, so this cancels and remain with 1 bracket. So this is x minus 3, then plus a c, okay, equals to x squared out of x minus 3 cubed. So what next? Okay, if we can substitute here, of course we're going to equate the numerators because the numerators are the same. X squared is equivalent to a into x minus 3 squared plus a b into x minus 3, then plus a c. Now, if x is equal to a 3, you discover that the first bracket and the second will go, okay? We have, we can say 3 squared, which is a 9. Let me not waste time. 3 squared is 9. So this is 9 equals to c. You have c directly, okay? To get the value of a and b, the easiest way is to look at x squared being equivalent to a into x minus 3 squared plus a b into x minus 3, okay? Now plus, which is a 9, okay? Let's expand out, and we have this is equivalent to a x squared minus 6a plus a 9 plus bx minus 3b then plus a 9, okay? So this is still will be equivalent to a x squared then plus a b minus, this is ax minus 6a into x, okay? Then minus 3b, then plus 18, okay? Now, equating coefficients of, let's begin with the x squared. Let's look at the coefficient of x squared. This side we have 1 is equal to the other side, which is a. Now, what about coefficients of x? Okay, on this other side, we don't have any coefficient of x, so we shall say 0 equals to b minus 6a, okay? So if 0 is equal to b minus 6a, then this means that b equals to 6a, which is equal to 6. And therefore, we shall have x squared out of x minus 3 cubed, giving us a, which is 1 over x minus 3, plus a b, which is our b is 6, which is 6 over x minus 3 squared, plus s, which is 9 over x minus 3 cubed. And we have resolved this in partial fractions. So, ladies and gentlemen, we are ending here today. We have some other 2 rules of partial fractions to discuss about quadratic factors and then repeated quadratic factors. Then we start resolving and integrating at the same time. So for this lesson, you should practice the rules of partial fractions. Remember, there are books we are using like Engineering Mathematics by K.S. Strode. You can go to Backhouse 2, it has this information, okay? Pure Mathematics by Tranter has this information, and Workout Equations, okay? You feel free to post a comment or write to me directly. If you need some more resources, I will see how I can facilitate you at, of course, some cost.